So, Jai Hind everyone. My name is Ritesh Sharma. I am from AKGEC Engineering College, Ghaziabad, and I am teaching the subjects the fundamental of electrical engineering in first year. So, today I am going to discuss about the single phase induction motor. The topic of my discussion will be the simple introduction of the single phase induction motor, then the double revolving field theory, in which we discuss about the why this single phase motor is not self starting induction motor, and then we discuss the types of single phase induction motor. So, let us start with the introduction. So, in single phase induction motors, we know that the single phase motor is widely used for the domestic purpose, some commercial purpose, where the power requirement is not too large. Okay. So, you can say that because of the single phase system is more economical than three phase system, and the power requirement is in the most of the houses, shops, offices are very small, and that power requirement is easily met by the single phase system. So, single phase induction motor is generally required the low power than the three phase induction motor, which is used in the industry purpose. Okay, that is why we also call it the fractional horsepower motor. So, they are quite simple in construction, they are cheap in the cost, reliable, easy to repair and maintenance. And due to all these advantages, the single phase motor find the applications in vacuum cleaner, fans, washing machines, centrifugal pumps, blowers, washing machine, etc. So, you can see that this single phase motor is basically which is required for all the domestic purposes. Okay, and it is very cheap, easy in constructions, as I just told you. Now, let us discuss something more about this single phase induction motor. Okay. Now, in this single phase induction motor, if we discuss the how the things is happening, so we will discuss with the help of double revolving field theory. Is a very important theory to understand the concept of the single phase induction motor. So, we know that in a single phase motor we have the stator and rotor, which I am not discussing in this particular lecture as the construction of this single phase, but we know that in every motor we have a construction stator side and rotor side. So, since this the single phase motor, the stator is having a single phase winding. Okay. So, suppose this when we apply the single phase supply to the stator winding, your stator flux is like the AC flux. Is like just like this. If you can see this diagram, this is the stator flux having the peak value phi 1 m. Phi 1 m is nothing but the maximum value of the stator flux. Now, what is this double revolving field theory? In double revolving, in this theory, the any alternating quantity can be resolved into two rotating components. That means we can any AC quantities or any alternating quantity can be resolved into two rotating components which rotate in opposite direction, and each having magnitude as half of the maximum magnitude, means they both having the equal magnitude and they are rotating in the opposite directions. So, if you can see this figure, we have the two fluxes, which the two component of this stator flux, one is called the forward flux, you can see, and one is called the backward flux. So, here we have the forward flux or forward rotating flux, and one is called the backward rotating flux or backward flux, as you can see here. Now, when this is at this position, at position O or at initial position, you can see here. So, here these two fluxes are equal and opposite. The two fluxes are equal and opposite, and they are rotating in the opposite direction. So at this position 0, this flux, forward flux, you can see that is in the direction, and your backward flux is just opposite to that, 180 degree of angle, and the resultant of this, the resultant flux will be the 0. So here you can see that the resultant is 0 at this position, at theta is equal to 0 degree. Now if suppose that this flux is at this position, that is 90 degree. So at 90 degree, these two components, the forward flux and the backward flux, will come at this position, since they are rotating in opposite direction. So at this position, when they are in the same direction, they will add each other, and it will be, the resultant will be the total flux of that is of this phi 1 m, that is maximum value of this. And similarly, this you can say that at different position, we can say that this flux will be rotated like this. Now they will, at angle is equal to 180 degree, it will be in different position. Suppose this backward will be at this position, that is phi b, and this forward will be in this position, that is phi f. So again they are in equal and opposite, the resultant will be the 0, and accordingly you can say that this fluxes is rotating in opposite direction with same speed, that is omega. So with this we can conclude that we have this stator flux, which is the alternating quantity, can be resolved into two fluxes, forward and backward, and they are rotating in the opposite direction. But what will happen now? Now because of this, we have two fluxes, forward and backward, there will be two torque on your rotor. That is called, since both are rotating flux, so it means that we have the two torque on your rotor. Okay, so what will happen now? So first is called the torque due to the forward field, that is torque TF. You can say one is called the torque due to the forward field, and one is the torque due to the backward field. And the resultant of both, you can see the dark shade line, this is the resultant torque of on the rotor, and you can see that the initial torque, the initial value of the torque when the rotor is stand still, that is 0. What does it mean? It means that at this position, when the rotor is at generally is at a squirrel cage rotor, and when the rotor is at this position, it will not rotate because we have both the torque, forward and backward torque on the rotor. The rotor will not be rotated because both the torque is acting on the rotor, and the resultant torque is 0. Your rotor will not move or rotate. So it means that from this we can conclude, since this is the torque slip characteristics or torque speed characteristic of the induction single phase induction motor. This is the forward speed, this is the backward speed. So since we know that this is the slip, we have already defined the slip in the 3-phase. So at this position, you can say that the slip is varying there. So as slip is equal to 1, here slip is equal to 0, slip is equal to almost 2. So this is how it is varying. So it means that this almost the initial torque on the rotor is 0, the rotor will not rotate, hence the single phase induction motor is not self-starting. So we can say that the single phase motor is not self-starting. Now how can we start them? The next question is, once we discuss the torque speed characteristics, means the double revolving theory. The double revolving theory says that this motor or this single phase motor will not start. Then what will we do? How can we start it? Now the method of start, right? The next topic is the types of induction motor, which means that how based on the method on which we start this motor will be the type of the induction motors. So you can say that we have the split phase induction motor, that is the split phase induction motor, that is the capacitor start induction motor, capacitor start, capacitor run induction motor, and the fourth one is the shaded pole induction motor. The 4 different types of starting methods in single phase. Now let us discuss one by one. This split phase induction motor means what? What we are doing, we are just splitting the phase of the stator flux. Okay, so let us take one by one, then discuss how this motor will be started. So first, the split phase induction motor. So in addition to the main winding, in what we do in the split phase, suppose let us draw the circuit diagram of the single phase induction motor. So in the single phase induction motor, we have a main winding. Suppose this is the main winding. This is the supply, single phase AC supply to the main winding. The voltage that we are provided to the main winding, and this is the one other winding. Switch is there. Okay, and this is our rotor. Let us suppose this is our rotor. Okay. So rotor, suppose the rotor is squirrel cage. These are the rotor bars or conductors. Rotor. So this is our main winding. Main winding, auxiliary winding or starting winding. You can say it's a starting winding or auxiliary winding. So you can say starting winding. This is the switch. We call the centrifugal switch. Centrifugal switch. So main winding and auxiliary winding. This is the current actually. So current, one is current in the main winding, suppose this is IM, and one is starting current, that is in the starting winding. This is the rotor actually. So this is the schematic diagram or the circuit diagram of the single phase induction motor. This is the supply that we are providing to our stator winding. Now, as the name indicates, split phase means what? We are just splitting the current actually. Okay, so when we split the current, this in this method, this starting winding resistance winding having the more resistance, means resistive winding you can say. So when we draw the phasor of this, winding, let us take the voltage which is the reference. I am just drawing it over here. This is our voltage V. That is the voltage that we are applying to our stator. So this is the IM, which is called the main winding current, and this main winding current is the inductive winding. So it's having the or you can say that so this angle between the voltage and the main winding current is quite large because this is the inductive winding. So current will lag the voltage by angle approximately 80 degree, 75 to 80 degree, because this is the inductive winding. Now another current which is flowing in the starting winding. When the starting winding current is there, and as I told you that this having a good resistance, so it means that this current is this is the starting current. Since the resistance having is a resistive winding, so it means that the angle is not so far. So one is this and one is this. So this is the angle between the starting current or starting winding current or main winding current. Suppose this is the alpha. This is the alpha. So now we have the two fluxes. We have the two winding current and the two fluxes, and these two fluxes are there which will create the angle, and because of this the torque will act on the rotor and it will rotate. This is the resultant flux will be there, and that resultant flux is rotated in certain direction and the rotor will try to rotate in that direction. So you can say that this alpha will indicate the torque angle to the motor. Now as you can see this, there is a centrifugal switch is there. So when your rotor attain about 75 to 80% of the synchronous speed, you know the synchronous speed of this will be the ns 120 f by p, where f is frequency, p is the in rpm, p is the pole. So when your rotor attain 75% to 80% of the synchronous speed, this switch will be open now. That's why we call it the centrifugal switch. And then when this open, this starting winding will be disconnected from the circuit. So the role of starting valve is when it will rotate to provide the starting torque or to rotate the our motor, and our motor will start. This is the basic important thing about this particular method. Okay, so this method is also called the resistive start method. Some of the application of this is this method having the low starting current, because angle is not so large, so having the low starting current and moderate starting torque. This is the observation from this particular motor, and these motors is used in the fan, blower, centrifugal pump, washing machine, grinder, lathe, air conditioning, fan, etc., etc. And the rating of this will be available from this range, 1/28 to 1/2 of the kilowatt. These are the rating. These types of motor, because torque is moderate. Torque is not high actually. So wherever we need the moderate torque, so we can use these types of method. So next method is called the capacitor start induction motor. So capacitor start induction motor, I told you that the method is called capacitor start induction motor and capacitor run induction motor. The difference is that the role of the capacitor in this capacitor start motor is till we start the motor, and in case of capacitor start, this capacitor is permanently connected to the motor. So let us discuss this method. So in the capacitor start, again we will take the circuit diagram of the same. We have a main winding. Let me draw the diagram. Main winding, start capacitor is there, then centrifugal switch is there, centrifugal switch, then and we have a rotor. Same diagram. Okay, these are the rotor bar conductors. Rotor. So again you can say that this is the main winding. I am not writing. This is I starting. This is the supply to the stator winding, capacitor, centrifugal switch. This is the rotor. Okay. Now this is a simple but circuit diagram of the capacitor start induction motor, and this is a centrifugal switch. Okay. Now again when we provide the supply to the main winding, we have the two current. One is called the main winding current, and one is called the starting current, just like the case of this two kits. But the difference between the two is that here we have the capacitor. So whenever the current will flow in this winding, there will be the current, starting current will lead the voltage, and current again in the main winding will lag the voltage. Okay, and if we take the resultant of the two, that is when we take the angle between the two current, the angle will be the large, that is the torque angle will be the more. I will showing by drawing the phasor diagram of this. So let me draw the phasor diagram of this. First, in case of this, let me erase this. So let us take one again, voltage as a reference. Then the current in the main winding is the inductive current, which is a higher angle. And the starting current, I told you the capacitor is there. So that capacitor will lead the voltage actually. That capacitor will lead the voltage. That is the starting current. This is the main winding current. And you can say that this angle is very, very large. So that because of this torque angle, this type of motor will provide the better torque than your previous motor, single phase. So this you can say that this particular type of motor is used where we have the large torque or better torque. So this is a resistance creating phase, but here we have the capacitor for this purpose, and we are familiar with the fact that the current flowing through the capacitor leads the voltage. This is what the constant which we are using actually. Okay. Now, so we are using these types of motors where we need the need of good torque. Like for example, they are used in the conveyor, grinder, air conditioner, compressors. So and they are at the high rating, 6 kilowatt rating is there. Okay. So another method, or in case of this capacitor start, capacitor run, the only difference is that the capacitor is permanently connected. In case of this capacitor is disconnected when it reaches the speed of the 80%, 70%. This capacitor again get connected. That's why we call it the capacitor start induction motor. In case of capacitor start, capacitor run, this capacitor is connected permanently, and because of this capacitor also help in keeping the power factor of the this circuit better. Okay. Again, the next method is called the shaded pole induction motor. In this type of method, we use this shaded pole method. So what is the meaning of this shaded pole? So if you can see this one of this pole is shaded. I have just taken the one pole, if you can see here, and this is the salient pole type, and this pole is shaded. The meaning of shading is that we use the shading band, a copper wire or a copper shading band is used for this. Now we have the two part, one is called the shaded part and one is called the unshaded part. This is called the unshaded part, this is called the shaded part. Now what happens when the flux is increased? The flux having the three regions, like when the stator current is alternating current, so the flux produced by the stator current is again alternating. So we have the three regions. One is the flux changes its value from 0 to maximum value. When the flux remains almost constant, when it is constant peak value. And the third is when the flux decreases from maximum positive value to 0. So these three regions we will discuss here. So when in the first region what happens? So let me tell you, in the first region, when the flux is d phi by dt is increasing, in that case this d phi by dt is increasing, flux is changing, this band will induce some voltage in that, because it's copper winding, copper band is there. So this band will induce some voltage because the flux is changing, and because of this voltage induced, and this band is short circuited, the current will be there. And because of this, what happens? The Lenz's law will be there, and the Lenz's law will oppose the mean flux. So it means that it will oppose the flux produced from this shaded part. It means that this unshaded part having the higher strong flux. Let me draw it now here. So this, if this band is there, so this shaded part will oppose the flux flowing through this side. It means the strong flux will be flow in this direction. and the weak flux will flow. Hence, the resultant magnetic axis will be here. You can see this is the resultant magnetic axis will be in unshaded part of this. Okay. Next, when the flux will reach to this peak value, because flux is going like this. This is the flux, AC flux. So this is the first part when it is increasing. This is the constant at peak phi m. So at this point, the d phi by dt will be 0. No flux change, no induction, no nothing. So it means that your flux, the resultant flux or magnetic axis will be the center. And in the third one, when again d phi by dt is again decreasing in this case. In this case, it will assist because it is opposing that. So in the third region, when it is d phi by dt is decreasing, in that case, this part, the shaded part, will assist the main flux, and hence this part will be having strong flux, and the magnetic axis will be shifted to this. So because of this concept, the flux is again rotated from unshaded part to the shaded part, and this will happen in all the poles which is around the rotor. So once we have the rotating field in the air gap, your rotor again it will try to rotate in that direction, as we have seen in the three-phase induction motor. So this concept is used in this shaded pole induction motor, this shaded pole. So I have discussed written all these things which I just told you. Region 1, region 2, which is constant, d phi by dt is constant, and there will be no induced EMF is here. And in region 3, the flux decreases from maximum value to the 0, and the rate of decreasing in the flux, and hence current is very, very high. So the copper band is short circuited and the current start flowing in the copper band due to this induction. So all the things which are, but there is some important part is there that some disadvantage is there for this type of motor, like it's having very low power factor. The power factor is low, starting torque is not so good, and efficiency is also again low. And again, why the efficiency is low? Because the copper losses are high due to the presence of copper band. So copper band will be there, the copper loss will be there, the efficiency might be low. And speed reverse is also difficult and expensive, as it required another set of copper rings. So these are some types of starting methods or the induction motor, single phase induction types, that definitely tell you the how this motor start and how we can start, and because the single phase induction motor is not self starting. So I hope this lecture will help you to analyze the concept and to understand the things. So thank you so much. Jai Hind.